Today's lesson is on lines in the coordinate plane, and I'm really hoping that most of this will be a review of Algebra 1 for you, so maybe it won't take us too long to get through it. Let's go ahead and write our essential question. The essential question is going to be, how can I use slope to determine if lines are parallel or perpendicular or neither? And also probably, how can I use what I know about slope to solve other interesting problems? But we don't have to write that down. All right, so what is slope? The slope of a line is the ratio of the vertical change or the rise to the horizontal change or the run between any 2 points. And sometimes you might see it written like this. And when you see something like that, that triangle is used to represent delta. And delta means change in. So the slope is the change in y divided by the change in x, or the difference, the change in the rise divided by the change in the run. So there's just some other terminology you might see. All right, so we have the slopes of parallel lines postulate that says in a coordinate plane, two non-vertical lines are parallel if and only if, hey, what is that? That's a biconditional statement, right? Parallel if and only if they have the same slope. So two lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. But why can we not use slope to determine whether vertical lines are parallel or not? What is the slope of a vertical line? Slope of a vertical line is undefined. I think there's a blank down further that will put that in, but just keep that in mind. The slope of a vertical line is undefined, so that's why we can't use slope to determine if two vertical lines are parallel. We just know that they always are. All right, so K1 and K2 have the same slope. How do I know that? Because right here they're telling me that these two lines are parallel. Therefore, by this parallel slope of parallel lines postulate, I know those two have the same slope. All right, what do we know about the slopes of perpendicular lines? In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are always perpendicular. Okay, and if the product of their slopes is -1, that means the slopes of two perpendicular lines are negative reciprocals of one another, right? Negative or opposite, negative reciprocals. Negative reciprocals or opposite reciprocals of one another. So for instance, in this little diagram here, if the slope of this line is 2 and the slope of this line is -1/2, then I know they're perpendicular because that product is -1. Okay? All vertical, yeah, here we go. All vertical lines have a slope of, well, it's not a number, it's undefined. It's undefined. Why is it undefined? Because the change in x equals 0, and that means we would have a 0 in the denominator. All horizontal lines have a slope of 0 because you got 0 in the numerator. All right, the slope formula is, remember we designate slope with a little m, and we say it's y2 minus y1 over x2 minus x1. Does it matter which point I let be x1, y1 and x2, y2? No, as long as I don't switch them up in the middle of my arithmetic. All right, so let's find the slope of this line here. y2, let's let this be 0.2, and let's let this one be 0.1. So y2 is going to be 3. And y1 is going to be -3. x2 is going to be 5, and x1 is going to be negative 4. So that slope there is going to be 6 over 9. So the slope of that line there is going to be 2/3. And I could see clearly that that does have a positive slope. Let me see if it works out. If I go up 2 and over, up 2 and over, 1, 2, 3, then I do hit that line. So I know that is the slope. Okay, just for fun, what would the slope of the perpendicular line be? The slope of the line perpendicular to this one would have to be negative 3/2, right? So the slope of a perpendicular line would have to be negative 3/2. All right, opposite reciprocal. Okay, what if we got 3 lines and we want to know which ones are parallel? Well, we have to find the slope of all 3 lines, and if any of the slopes are the same, then those would be the lines that are parallel. So what do we have here? We've got, what are these labeled? J1, J2, and J3. So let's do the slope of J1. This is J1 right here, and we've got 10 minus 2 divided by negative 1 minus negative 5, so that's going to give me a plus 5. So that's going to give me 8 over 4, which is 2. I can tell indeed, yep, those lines do all have a positive slope. That's J1, so let's do the slope of J2. Here's J2 right here. So that slope is going to be 9. Here's my other point. Took a second to see that. 9 minus 1 divided by 2 minus negative 2, which is plus 2, and that gives me 8 over 4, which is 2. So definitely those two are parallel. Let's come over here and find the slope of J3 and see if it's parallel to the other two. The slope of J3 is going to be 7 minus 2 divided by 5 minus 2. So that slope is 5/3. So that's the one that is not parallel. So I'm just going to mark these. J2 is parallel to J1, and there's my little parallel marking. J3 is not parallel. All right, we do have 3 forms we can write the equation of a line in. Slope-intercept form is the one we're most familiar with, and we always want to get our equation in slope-intercept form so that we can graph it. And that says y equals mx plus b, with m being the slope and b being the y-intercept. Point slope form, y2 minus y1 equals the slope times x2 minus x sub 1. And whenever you have the slope of a line and you have a point on the line, you always want to use point slope form to get the equation of the line into slope-intercept form. We'll do an example or two here in a minute. And standard form, which you need to know, but you probably will never be asked to put an equation of a line in this form because you can't graph it when it's like that. But the standard form is ax plus by equals c. All right, couple of examples. Line K1 has the equation y equals negative 2x plus 5. Line K2 is parallel to line K1 and passes through the point negative 4, 3. Write the equation of K2. Okay, what does this tell me? The fact that they're parallel? It tells me they have the same slope. So what did I tell you just a second ago? I have the slope, I have a point on the line, so anytime I have those two pieces of information, I'm going to use point slope form. So y2 minus y1 equals m times x2 minus x1. And you had quite a few of these problems on your diagnostic assessment too, so hopefully you haven't forgotten that. All right, so let's pick, we have 3, so we're gonna just turn this y2 into y because we have to leave an x and a y in our equation. So we have y minus this y right here So y minus 3 equals, what's our slope? Oh, it's the same as the slope of this line because they're parallel. So that's negative 2 times x minus negative 4, because our x value is right here of our point. So let's just simplify that, and we get y equals negative 2x. And let's see, this will be positive 4 down here, so negative 2 times positive 4 is going to be negative 8, and negative 8, and then I'm going to have to add this plus 3, so negative 8 plus 3 is going to be negative 5. So the equation of my line there should be negative 2x minus 5. And of course, if we want to check that out, we can graph it and make sure. All right, write an equation of the line that passes through point P and is parallel to the line in the given equation. All right, this is just like the one above. So of course I'm going to pause here. I'm going to let you do this using point slope form, because we have a point, we got the slope. So do this and then come back and check it. All right, I got y equals negative 3/2 x plus 6. If you did not get that, then please pause here, look over my work, and check yours and see where you may have gone wrong. All right, here's another example for us. R1, line R1 has an equation of y equals 3x plus 5. Find an equation of a line R2 that passes through this point, oh, and is perpendicular. Okay, well, we're going to do just what we've been doing, only this fact that this line is perpendicular tells us that the slope of this line R2 is going to be what? It's going to be negative 1/3, right? So now that you know the slope, you've got a point, so pause right here again and work this problem and then come back and check. I got y equals negative 1/3 x plus 2. Please check your work. If you got this answer and you're comfortable, move along. If you did not get this answer, then please pause and double check your work. A final problem here. Think about a plan. Line L1 contains negative 4, 1 and 2, 5, and line L2 contains 3, 0 and negative 3k. What value of k would make those two lines parallel? Well, I think, of course, I got to use the slope. So let's find the slope of L1. The slope of L1 is going to be 5 minus 1 divided by 2 minus negative 4, which is 2 plus 4. So that's going to be 4/6, which gives me 2/3. Okay, that's the slope of L1, and if L2, I'm trying to find k that's going to make L2 be parallel, which means it's going to have the same slope. So the slope of L2 is also going to be 2/3, right? So let's go to L2 here. I know it's got to be 2/3 if it's parallel, and then let's look at our points that we have for L2. So it's going to be 0 minus k, because there's the y value that I don't know, divided by 3 minus negative 3, which is 3 plus 3. So that gives me negative k/6. So let me just write this 2/3 here closer. So negative k/6 equals 2/3. So how can I solve a proportion like this? I can cross multiply, right? Take the cross product. Negative 3k equals 12, right? And of course, if I divide both sides by negative 3, I end up with k equals negative 4. And what is the question? What value of k? K is negative 4. So the 2 points that L2 goes through would be 3, 0 and negative 3, negative 4. All right, write yourself a summary. We'll see you next time.